today's lecture, we'll talk about semantic segmentation, and we'll see like how this is different from the binary segmentation we studied or the image segmentation we studied. And both of these are like kind of correlated problems. And then we'll have the final lecture, lecture 16th on Thursday. That will be on instance segmentation. Okay, so all these problems are related. And I think both these lectures are not that heavy. So we will try to cover like different concepts and try to cover like the important concepts in both of these lectures so that you understand like the differences between these problems and also have a better understanding of how we can solve these problems. Okay, so let's talk about semantic segmentation. Now, before going to the solution, how this problem can be solved, let's try to understand what semantic segmentation is. So image segmentation, we saw the goal was given an image, we wanted to get an idea of like what different segments or what different regions we have in that image. Okay, and it could be like as simple as foreground versus background. For example, if we have some object in a scene and we want to separate like that object from the background, that would be like a very simple case. Now, semantic segmentation is kind of related because again, we are going to make like this pixel-wise prediction. For example, like these three images shown on the top row over here. Okay, if you look at this image, so in semantic segmentation, again, we are going to make prediction about each pixel on this image. And that was the case with binary segmentation and image segmentation as well. Now, the difference will be, in this case, we want to assign some kind of semantic meaning to each pixels. Okay, if you think about binary segmentation, there also, it was kind of semantic because we were saying that which pixel is foreground and which pixel is background. Okay, so it's not completely semantic, but there was some information tied there as well, right? So in this case, we will clearly say that, okay, each pixel is a grass because grass has a semantic meaning, right? And whether each pixel is a sheep or not. So that's like the commonality between segmentation and semantic segmentation. Now, if you try to differentiate this with like the image segmentation we studied, for example, the SLIC algorithm, right? So there, the goal was to get like different small segments from this image, where what might happen is you might get like different segments for the sheep. So each segment actually belongs to sheep. So it has some kind of tie to semantics, but then you can't say that, okay, this is your whole sheep. It will just part of it. Okay. So that's like one big difference between what we're trying to solve here and what we tried to solve earlier. Similarly, you can see like in the second image, you want to say that, okay, which pixel belongs to a car and which pixel belongs to a building or a road. Again, you might imagine that these are like simple scenes. For example, this image on the left, you can just say that, okay, the green grass is the background and whatever pixel you have of the sheep, that's a foreground. So you can basically solve this as a foreground, background, or binary segmentation problem as well. Okay. So, but in more complex scenarios, what will happen is instead of just having two different categories, we'll have multiple categories, right? For example, you have road, you have car, you might have like sky as well, you might have trees. So there will be multiple categories. And for each category, you will have to say that, okay, which category like each pixel belongs to. Similarly, here you can say that you have water, you have pixels for cow and for grass. All right. And more likely, like in a more realistic scenario, you will see like the image will be very, very complex and not just 3, 4, 5. You might have like hundreds of different categories just present in one different scene. And again, depending upon like what different categories you're interested in. So that's semantic segmentation. And of course, for deep learning, you know, not just deep learning, like any computer vision problem, you need like some kind of data set to work on. And for semantic segmentation, we have Pascal VOC and MS COCO. So these two popular data sets are mainly used. Okay, and there are other data sets as well, but those two are the most important ones. So this is like one key part of like scene understanding. If you think about autonomous driving, then we discussed this earlier as well, that if you have a automatic driving car, then you have a, like, let's say a camera which is capturing what's happening in the surrounding or in the neighborhood. Then just saying that a car is present, a person is present, that's not enough. Then we talked about object detection, right? Which will say, okay, which particular, like you will give like the bounding box of each category, which will say, okay, this is a person, this is a car. Now, if you have like those objects which can move and which you can define using a bounding box, that's fine. But let's say you have a object which is not like, which cannot be fit like in a rectangular shape, right? So for example, this walkway. So if you have to draw a bounding box for this, it's going to be mostly covering the whole image, and that's not useful at all. So in that sense, therefore, the semantic segmentation will play a very important role. You can also carve out the boundaries of odd shaped objects. For example, this sidewalk, or for example, like the road over here, right? You need to find the road boundaries, and object detection is not going to solve that for you. And if you don't have the road boundaries, you don't know those lines, then it's, I mean, your car will not drive automatically, right? You don't know like where to drive. So that's why, so that's like just one simple application where semantic segmentation is very useful. Okay. So there are many others, for example, medical diagnosis, where you have to get like the fine boundary of, for example, if you're doing tumor detection, so you need to know like exactly where the tumor is present. And of course, like it could be your fun projects as well, where you're doing some kind of image editing. There as well, if you, let's say you want to carve out some of the objects which you don't want in your images, then you need those fine boundaries, right? And then you'll just remove those objects from your images. So a lot of different applications you can have in semantic segmentation. So assistive living, like this is another very important application area. For example, like if a person is not able to see like what's happening in the surrounding, right? In that case, if there is automatic system which can give like a very good idea of what's happening in the neighborhood, whether it's crowded, whether it's good to walk, and there is no, let's say, maybe potholes on the walkway. So all that is very, very useful, and you need semantic segmentation to solve that problem. Okay, again, the medical diagnostics, we talk about that. Again, image editing, it can be very useful here.